Hey guys, this is Siddarth and welcome back to my channel. Today I'm going to be giving a basic introduction to solving numericals in curve beams. So the basic thing that we need to find out before solving any numerical is the value of Rn. So Rn is the radius of the neutral axis. So in this video I'm going to show you how to find the radius of neutral axis of various cross sections for curved beams. So first let's start off with a circular cross section. So first we draw the center line, and we can see that from the centroidal axis to the center line the radius is given by RC. So RC is nothing but the radius of the centroidal axis. The neutral axis, which is below the centroidal axis, has a radius of Rn. The distance between the centroidal axis and the neutral axis is given by E. Next, we denote the distance of the inner and outer fibers from the center line. So Ri is the distance of the inner fiber from the center line, and Ro is the distance of the outer fiber from the center line. So after this we can write the expression for the radius of neutral axis. So the radius of the neutral axis Rn is given by the square root of Ro plus the square root of Ri whole squared divided by 4. So that's the expression of the radius of the neutral axis which we use while solving problems. So that was the radius of neutral axis for a curved beam of circular cross section. Now let's move on to the radius of neutral axis of a curved beam of rectangular cross section. So let's begin by drawing a rectangle which denotes the rectangular cross section of the beam. First we draw the centroidal axis and then the neutral axis. Now we draw the center line, and similar to the previous case, we denote the radius of the centroidal axis and the radius of the neutral axis by RC and Rn. So after this we again denote E, that's the distance between the centroidal axis and the neutral axis. And this time, since we're using a rectangle, B is the breadth of the rectangle and H is the height of the rectangle or the length of the rectangle. And next, again similarly to the previous case, we denote Ri and Ro, that's the distance of the internal fiber from the center line and the distance of the outer fiber from the center line. So Rn, that's the radius of the neutral axis, is given by H divided by natural logarithm of Ro divided by Ri. So this is the value that we find out while solving problems. Next, let's move on to curved beams of trapezoidal cross sections. So we begin by drawing a trapezoid. The trapezoid represents the trapezoidal cross section of the curved beam. So let's first draw the centroidal axis and then the neutral axis which is below it. Then let's draw the central line, and similar to the previous cases, again we denote the radius of the centroidal axis by RC and the radius of the neutral axis by Rn. Since this is a trapezium, we need to now label the opposite parallel sides of the trapezium. The bottom side of the trapezium is the inner fiber of the curved beam, so it's represented by Bi, and the top side of the trapezium is on the outer fiber, so it's represented by Bo. Next we represent the height of the trapezium by H, and again like the previous ones we show the distance of the internal fiber and the outer fiber from the central line by Ri and Ro respectively. So now, like the previous cases, we again write the expression for the radius of the neutral axis. So in this case it's kind of a long expression, so it's given by Rn is equal to half into height into Bi plus Bo whole divided by, we have to draw a long line here, whole divided by Bi into Ro minus Bo into Ri whole divided by H into natural logarithm of Ro divided by Ri minus Bi minus Bo. So this is the expression for the radius of neutral axis for a curved beam of trapezoidal cross section. So finally we move on to the last case. So that's curved beams with an I-shaped cross section. So let's begin by drawing an I shape which represents the cross section of the curved beam. So again, like previous cases, we start off by drawing the centroidal axis and then the neutral axis which comes right under the centroidal axis. So we draw the central line and then we denote the radius of the centroidal axis and the radius of the neutral axis by RC and Rn respectively. Next we have to denote the width of the sides of the I shape. So the width of the side of the eye that's on the inner fiber will be given by BI, and the width of the side of the eye which is on the outer fiber is given by BO. So after this, since there's a middle section also, the breadth of the middle section or the width of the middle section is denoted by B2. So next we have to denote the thicknesses of each of these sections. So the thickness of the section on the outer fiber will be given by AO, and similarly the thickness of the section on the inner fiber will be given by AI, and the middle section the thickness will be given by A2. So now, like previous cases, we again have to denote the distances of the inner and outer fibers from the center line. So again it's given by Ri and Ro. So now it's finally time to write the expression for the radius of neutral axis. So that's given by Rn is equal to A divided by, draw a long line because there's lots of stuff to write, Bi into natural logarithm of Ri plus Ai divided by Ri, put that in brackets, plus B2 into natural logarithm of Ro minus Ao divided by Ri plus Ai. Now put the whole thing in brackets, plus Bo into natural logarithm of Ro divided by Ro minus Ao. So that's the final expression for the radius of neutral axis of a curved beam with an I-shaped cross section. At this point you may be wondering what the value of A or the area is. So to find out the area of the I-shaped cross section is pretty simple. First we denote the different cross sections as 1, 2 and 3, and then we can see that 1, 2 and 3, the cross sections are all three rectangles. 1 is a rectangle, 2 is a rectangle, and 3 is a rectangle. So area is equal to the sum of the areas of the sections 1, 2 and 3. So we know that 1, 2 and 3 are rectangles. So we just use the basic formula for the area of a rectangle, that is area is equal to length into breadth. So we do that for all three cross sections and then add them up in order to get the final area, that is A. So that's the end of this lesson. I hope you guys enjoyed it. If you did, please like, comment and subscribe, and also please feel free to share your feedback as it'll help me improve this channel.